Welcome. My name's David Wood, and I'm here to talk about the case for singularity activism. This is actually a version of a talk I gave a couple of days ago on the 29th of April to a meeting of London Futurists at Birkbeck College. It was a well-received talk, but that event was not recorded. So I'm now sharing an updated version of this talk, which in some ways is improved because it benefits from feedback during the meeting itself, more feedback during the after the event discussion in a nearby pub, the Marlborough Arms, and yet more feedback which I've received via email and social media. This topic of the singularity and singularity activism is arguably the most important topic that London Futurists has ever discussed. Now, we've discussed topics like this many times before, but they've never been quite so urgent. And the scenarios ahead, the choices, the risks and opportunities have never been quite so pressing. So let me talk about these words, singularity and activism. The word singularity is often misused. It's overused, but I want to keep using it. It's a good word. It describes something singular, something unprecedented, and I'm going to use it to mean the unparalleled acceleration of AI capabilities, all the way to reaching beyond human general intelligence. I say this is a self-propelled acceleration because as people develop one set of AI capabilities, these capabilities can be used in turn to help design and develop an improved set of AI capabilities. And that improvement cycle is accelerating. As I said, it goes all the way to human level. And part of what that means is that it is going beyond human understanding. I don't just mean beyond my understanding or beyond your understanding. It's going beyond the understanding of the people who design and create these systems. There are many surprising features in the latest AI systems, so much so that people are taking to calling them, with some justification, not just artificial intelligence, but alien minds. And as they move beyond human understanding, the risk is that they are moving beyond human control. There are many outputs of these systems which we did not expect and which are not to our liking. Now, I'm not here today to offer a singularity pacifism. There's nothing we can do. I don't believe that at all. There are plenty of things we can do. Nor am I here to offer a singularity cheerleading, in which people say, let's accelerate AI capabilities as quickly as possible without any restrictions. I think that's irresponsible, and I'll explain why. Conversely, I'm not here to offer singularity obstruction, a kind of jihad, a Butlerian jihad, to refer to the work of the science fiction Dune. No, I'm offering something rather different, activism. But finally, let's be clear, I'm not offering doomerism either. I'm not saying we're all doomed and there's nothing we can do about it. I'm saying there is plenty of significant things we can do. Hence, singularity activism, which I describe as the purposeful steering of AI capabilities. And I'll be explaining what I mean by that. But first, let's go to the top of the slide again. General intelligence. What does that mean? There are some people who say with some sophistry, there are multiple kinds of intelligence, which is true. Therefore, there's no such thing as general intelligence. Therefore, they say there's no such thing as artificial general intelligence. And so people like me who talk about AGI, artificial general intelligence, can be ignored. Well, what I mean by general intelligence is, in simple terms, the difference between the capabilities of the creature on the left and the capabilities of the creature on the right. The one on the left has more muscles. If there was a naked fight between a chimpanzee and a human, very likely the chimpanzee would be victorious. That's not what general intelligence is. It's brain, not brawn, but it's a particular type of brain capabilities. After all, chimpanzees have been proven in some ways to have better short-term memory than us. Our general intelligence refers to a mix of capabilities. They are whatever is needed to help us get things done, to get complicated things done in complicated environments. Or, in a definition that is often used, general intelligence is the ability to achieve goals in a wide range of environments. And it breaks down to a number of particular skills: the skill to be able to observe, to see what's happening and make sense out of it. Therefore, in order to be able to predict what's going to come next. More than that, the ability to predict what will happen if there are interventions changing the situation. What will the outcomes of these interventions be? General intelligence also includes the ability to put these plans into action, step by step, and to reflect whether these actions had the desired, intended, predicted consequences. And in case they didn't, general intelligence involves the ability to learn, to try something different with the point of view of a deeper understanding. Stupidity is sometimes said to be trying the same thing again and again and expecting different outcomes. General intelligence avoids that. So loosely, that's what general intelligence is. Is it possible that just as we exceed the general intelligence of chimpanzees, and therefore the fate of chimpanzees is entirely within human hands, there will in the future be some new species with significantly more general intelligence than us. A species running not on biology, but on computing substrate, silicon or whatever. Now, most people, if you ask them this and they think about it, most people will say, yes, it would be possible at some time in the future, probably a long time in the future. That's what people at least used to say. But let's look more closely at this question of when there may be artificial intelligence surpassing us in this way. To answer that question, I'm going to refer to the results shown on a website, Metaculus.com. Metaculus is, as it says here from the website, a community dedicated to generating accurate predictions about future real-world events. That includes events in politics, economics, and in the progress of technology. And these accurate predictions are achieved by aggregating the collective wisdom, insight, and intelligence of the participants, where the contributions are weighted by the extent to which participants have proven skills as demonstrated by previous predictions and as demonstrated by the assessments each participant can make of others' contributions. Now, on this site, I want to look at one particular prediction. It's a prediction that's been in place since almost the beginning of the site in January 2020. The question the contributors were asked to comment was, when will the first weekly general AI system be devised, tested, and publicly announced? And one benefit of the Metaculus site is they define their terms pretty carefully. So they explain what they mean by weekly general AI system. It's a single piece of software which must be able to do multiple things. Namely, first, it should be able to reliably pass not a trivial Turing test, but a sustained Turing test of the type that would win a particular prize in a particular setup. And this involves a human judge who is knowledgeable about the capabilities of artificial intelligence systems. It involves a sustained dialogue. Now, there are many people who have already been caught out by what ChatGPT and other generative pre-trained transformer systems have produced. If they don't know where these essays or these poems or these dialogues have come from, many people are prepared to think this must be from a human. But this doesn't mean these systems can pass these types of Turing tests, because if you get a knowledgeable judge, they know how to ask questions that will trip up the chatbots so far. So that's the first of 4 things that software needs to do to meet this criteria. Secondly, it needs to be able to score at least 90% on a robust version of what's called a Winograd schema challenge. This refers to bits of text like this. Now, a human can read the text, and then at the end, if they are asked about one of the pronouns shown, here the word his, if they are asked whose wallet is it, the human is able to answer, it's the rich old man's wallet. Now, there is a criticism of many pieces of AI that they are just stochastic parrots, so-called. In other words, they can mimic, they can put words together in a plausible order, but they don't really understand. And it's true, a piece of software that didn't understand would not be able to answer such questions, at least questions that it's never seen before. However, some pieces of AI are making progress with these Winograd schema challenges. The third thing that the software needs to be able to do is to score at the 75th percentile of the full mathematics section of a standard SAT exam. And here, it's just given images of the exam pages, and they have to be exam questions that the AI has never seen before and are not part of its training data. And the fourth thing that the AI needs to do to pass this test is to fare well in a classic Atari game called Montezuma's Revenge. It needs to be able, in the equivalent of less than 100 hours of real-time play, to learn and explore all 24 rooms of this game. It's not a game I've played myself, but I am told that even intelligent humans struggle to make progress because you have to think very hard and understand cause-effect relationships over an extended period of time. So, a piece of software that does all that will be pretty intelligent. What do members of the Metaculus community think will be the timescale in which there's a 50% chance that such an AI will not only exist, but it will be publicly announced and publicly tested? Here are the results, and I'll talk you through what's visible on this graph. Let's look at the middle of the 3 lines. That is the community median estimate. That's the aggregation, weighted aggregate of the various estimates for when people think there's a 50% chance that the criteria is met. And you can see, for example, that in April 2020, people thought this would be quite a while into the future, actually 35 years into the future. And if you had asked me roughly the same time or a bit earlier, I probably wouldn't have said 35 years, I would have said something like 25 years, but it would be quite some time in the future. But let's look at how that prediction changed as time went on. There were many new AI systems released in 2020, which made people wonder. Progress is faster than had been expected, so that by October, the forecast was no longer 35 years in the future, but 13 years in the future. In 2021, the predictions varied again. It went up in part because people looked at these recently released AI systems and started to be more negative about them in terms of their faults. But then yet more systems were released with even better capabilities. I'm not just referring to chat pieces of software, I'm referring to graphics generation software as well, and video generation software, and many other capabilities, such as DeepMind's Gato, which was a single piece of software that could do 602 different tasks at a high level of capability. So in 2022, it's no surprise that the estimates came down again, so that by October, the forecast was just 6 years into the future. AGI, just 6 years away, according to that estimate. And in 2023, the estimates have come even closer to the current date. So in April 2023, the forecast was that AGI in this weak general form would only take 3 years to come into existence. There's more in this picture. If we look now at the top and the bottom lines, they give you the estimates by which people are pretty confident something will have happened. That's the 75% probability line. And most recently, if people were asked to give a date by which they were 75% confident this week AGI would be present, it was 2030. And if you ask them to be more risky, to give a 25% confidence prediction, that's the bottom line, that's June 2024. 14 months into the future. I should say that this Metaculus site has a number of other definitions of AGI, some of which are more demanding. The more demanding one, its prediction forecast has come closer and closer to the present day as well. That, the last time I checked, was showing February 2032, 9 years into the future. So that was an aggregate forecast. Now let me take the forecast of a particular distinguished individual. Some of you may recognize this as being Professor Geoffrey Hinton of the University of Toronto. He actually grew up in Wimbledon in London, went to school there, studied computer science at King's College London, went to do a PhD in artificial intelligence in Edinburgh, where he ran up against some opposition. He wanted to study neural networks, and at that time, the established wisdom was that neural networks were a waste of time. But Geoffrey Hinton persisted. He ended up, after some time in Carnegie Mellon in the US, he is a leading professor at the University of Toronto, and he joined Google Brain. He is often called the godfather of deep learning, or one of 3 godfathers, but he is in some ways the most senior of the 3 because of his long advocacy of neural networks and because of some breakthroughs, which I'll describe shortly, for which he was responsible. But I want to move to what he said in an interview on CBS Saturday Morning TV just a few weeks ago. He was asked about how long it would take to get to artificial general intelligence, the same question I've just been reviewing. He said, until quite recently, I thought it was going to be like 30 to 50 years before we have general purpose AI, but now I think it may be 20 years or less. Now, the CBS interviewer asked another question. Some people think it could be like 5, as we saw from the data we've just been looking at. Geoffrey Hinton's reply, I wouldn't completely rule that possibility out now. Whereas a few years ago, I would have said, no way. The conversation continued. The interviewer asked, "Are we close to the computers coming up with their own ideas for improving themselves?" Yes, we might be. Indeed, there are many ways in which AI tools are already proposing improvements to AI tools. The interviewer continued, "Then it could just go fast." Professor Hinton said, "That's an issue. We have to think hard about how to control that." And can we? Professor Hinton's answer, "We don't know. We haven't been there yet." It's true, we've never created an AI which is more intelligent than us in general ways. We can't anticipate exactly how it's going to behave, exactly how much we will understand of it, exactly what goals that AI might turn out to follow. But Professor Hinton didn't advocate pacifism or doomerism. He said, "We can try." The interviewer continued, "What are the chances of AI just wiping out humanity?" The reply, "It's not inconceivable." Very candid words. And since this interview was recorded, indeed, since the presentation I gave at Birkbeck, Professor Hinton has announced he is resigning from his tenure with Google. Why? Because he wants the freedom to speak out about the dangers of uncontrollable advanced AI without needing to worry whether he might be falling foul of policy set for communications by his employer, Google. Serious stuff. So we're now in the situation where people like Professor Hinton and others, Professor Stuart Russell, for example, Professor Max Tegmark, they are featuring on TV shows. A bit like in this film, Don't Look Up, where there were some people who recognized a danger and they appeared on news shows. You can see in this picture the news presenters here who are for a while amused, bemused by the prediction of doom before hastening on to the next celebrity scandal item on their agenda. But the scientists here say, please do look up. Please do pay attention. It was said at the time this film was released, it was a commentary on people ignoring the threat of climate change. It can also be seen as a commentary on people ignoring the threat of incoming artificial general intelligence. Now, in the movie, there are some spoilers coming, so if you want to avoid hearing these spoilers, please pause this video and move forward to the next slide. In the video, there is, after a while, reluctantly, an agreement to try and deflect this incoming meteorite. We might say to control it, but that plan is scuppered when people think they can make a fortune by taking advantage of all the minerals on that meteorite. So they frustrate the plans to slow down or deflect the trajectory, and another spoiler, it leads to the destruction of all of humanity. Okay, that's just a film. But let's now look more closely at that threat. And I want to talk you through now, in one of the most important slides in the whole set, 6 levels of understanding AI. And the problem is that many people are stuck on some of the earlier stages. And the reason they say we don't need to worry about incoming AI threats is, and then they offer a reason that makes sense from the level of understanding they have reached, but they are not aware of the insights and important facts from the higher levels of this understanding. So the ground level of understanding is you've watched Hollywood films. I'm not referring to Don't Look Up here, but there are other Hollywood films featuring artificial intelligence, or you've read science fiction. And that's entertaining, and it may give you some idea, but it is hopeless to put you in a good situation to predict what's likely to come in the next 5 to 10 years. The next level of understanding is you know what AI was like around 2011 or earlier. That was the period when classical AI, now sometimes called good old-fashioned AI, dominated. Logical systems, systems of symbolic manipulation, lots of if-then-else rules, rules that were created by talking to experts and then modifying, and some learning systems, but that will not serve you very well if that's all you understand about AI, because in 2012, the team led by Professor Geoffrey Hinton at the University of Toronto made a breakthrough in neural networks, deep neural networks, so it has come to be known as deep learning. They achieved results far better than anybody had achieved by any previous AI. They did it by a number of steps. They took advantage of a different type of hardware, not the central processing unit inside computers, but the graphics processing unit, which could perform lots of parallel computations at the same time. And these parallel computations are what makes calculations in deep neural networks feasible. They also took advantage of lots of annotated data, including lots of images that had descriptions appended to them. These descriptions were supplied by humans who were paid via the Amazon Turk service to briefly describe what was in these pictures. This database, ImageNet, was created by a Stanford professor, Fei-Fei Li. And this was used for the training of these deep learning systems, which Geoffrey Hinton, together with a team of two of his students, one being Ilya Sutskever, who subsequently has been a co-founder and chief scientist at OpenAI. Finally, they managed to tweak the venerable backpropagation algorithm with some other modifications so that the whole system achieved great results in the annual competition for image recognition. And it turned out that similar results worked in other fields too. So there was much better machine translation from one language to another. There was much better speech recognition. There was much better recognition of what was in various medical scans. So that has caused a new revolution, a tide of momentum in the field of AI. But if that's all you know, then again, you are not in a good situation to speak with any confidence, with any authority about what's likely to happen next. Because there was another breakthrough that started actually in 2017 with the publication of a paper by a group of researchers in the Google Brain division of Google, the division that was at the time headed by Jeff Dean. They found a way to make self-supervised learning work very well. Self-supervised learning is when the system is able to learn from data that has not been marked up or annotated by humans. And so it's fed lots of text from all over the internet, and it's able, just by studying this text in various clever ways, what it does, in fact, is it covers up in its own mind various words in these sentences, and it tries to work out from the context, the other adjacent words, both before and after, what the covered up word is likely to be. And it does this again and again until it gets much better at it. And people had an idea for a long time that something like this would be possible, but it never worked until this new paper describing so-called transformers came up with a system that worked. And the first practical transformers was in something called BERT that Google had in 2018, and they have gone on in leaps and bounds since then. A second major recent revolution in AI. It's led to what some people call large language models. That's not a completely adequate description. Hence, I've got here large language multimodal models, because it makes sense not just of text, with words covered up, so it guesses what the covered up words were and is able to predict the structure of text. It's able to understand syntax. The same transformer mechanism works with covering up bits of pictures. It works with taking a picture and converting it to low resolution and trying to work out what the good high resolution version of that would be. The same transformer mechanism works. And as a result, these systems are able to generate pictures, texts, videos, sound, and so forth. Hence, some people also call them generative large language multimodal models. And that sounds like a mouthful, but the reason it's done is somewhat controversially, so that the whole thing can be called golems. Now, I say controversial. A golem is a mythical creature which is brought to life and exhibits alien minds. And that is, in a way, what we've got. All right, so if you understand transformers, that may take you up to about 2021. And that is, again, insufficient for you to reliably predict what's coming next. Because what happened after that is that the large language models started demonstrating what we call emergent capabilities, more features than were expected. As the systems were scaled up, as they got larger, they didn't just get better at what they were doing, they started doing new things that had not been expected. So one example is so-called one-shot learning. AI has often been criticized in the past for not being able to duplicate what human children can do. A human child is able to tell the difference between a cat and a dog by just seeing a few examples of each. The child doesn't need to be shown a million examples of each. Well, these large language models, sometimes called foundation models, have the same capability. They are trained through a lengthy process, a bit like a child's brain is in effect trained by hundreds of millions of years of evolution. And it's then able to pick up new skills very quickly. So these large language models are, once they are trained, often able to answer questions on some new feature without that feature being trained. Just by seeing one example, they're able to extrapolate. And that's just one example of emergence. Jeff Dean, who I previously mentioned, head of Google Brain for many years. He has recently been promoted to a new position inside Google, chief scientist. He remarked that we are seeing many examples of emergent features. We are seeing many examples of emergent features in these large language models. What we don't have so much of is an understanding of where these capabilities come from. So that may take you to about 2023. And guess what's coming next? That, again, is not sufficient for you to understand the road to artificial general intelligence that we may travel over the next few years. To be able to anticipate what's coming next, there is one additional thing that needs to be added to this picture. It is combination systems. By a combination system, I mean that in addition to the successes and limitations of large language models, other aspects are bolted together with them, combined in various ways. For example, a technique such as artificial neuroscience is already being applied to make sense of how these large language models, in some cases, come up with their answers. It's called artificial neuroscience by reference to original neuroscience, which tries to work out what's happening inside a brain to convert various inputs to various outputs. It's the same with artificial neuroscience, except that for a real brain, there's a lot of guesswork involved because we don't like to cut open people's brains whilst they're in the middle of calculations and thoughts most of the time. But with these large language models, it's easier to inspect. And what people are finding as they are doing these inspections and starting to see how these features emerge is they are realizing, gosh, this is a very inefficient way to achieve a certain goal. If the system could somehow be re-architected if the network could be reconstructed, the same results would come perhaps 10 times faster. So that's an example of combining ideas from what has been called different tribes. And here I'm using tribe in a good sense of the word, the sense introduced by Pedro Domingos, who is now an emeritus professor at the University of Washington, in his 2015 book, The Master Algorithm. A book, by the way, which has been noticed on the bookshelves of none other than Xi Jinping, the leader of China, alongside books by Marx and Lenin, Hemingway, and Dickens. I'm not sure whether Xi Jinping has actually read this book in full, but it is quite likely that many of his advisors and colleagues are familiar with at least the outlines of these ideas. The idea is that progress, true progress, faster progress will come when there is a convergence of ideas from several of these so-called tribes. The symbolists were the ones I referred to from the good old-fashioned classical AI days. The connectionists were the ones who were rejected for such a long time with their ideas that we could learn from neuroscience with neural networks until 2012 and this Big Bang. But there is likely to be input from evolutionaries, Bayesians, and analogizers as well. So that's the idea of tribe convergence. And I have to say in passing that some of the progress in the last few years has been to another kind of convergence that's entirely within this connectionist neuroscience tribe, where various sub-tribes have been able to cooperate and collaborate as never before. It used to be that different types of networks, recurrent neural networks for speech recognition, convolutional neural networks for image recognition, and so forth. There used to be different disciplines, different specialities within that field. With transformers, the different groups can share their ideas, share their results, share their special techniques more readily, which is why, again, there's been an acceleration. So there are plenty of capabilities making it possible for us to reach AGI in just a few years. Let me recap. First, there is the potential to scale up today's large language models to new heights. This could mean more training data. That could be, surprisingly, it can be synthetic data. You can get one AI to create data, and another AI can read it and learn from it, and actually reaches a higher level of intelligence as a result. It may also be training data which has been converted from radio programs, converted from YouTube videos, as the audio there has been turned into text. Scaling up these large language models needn't just be a matter of more quantity, it can be a matter of better quality. And today's large language models already have some preparation done to the data. It's not completely raw. I said it was unsupervised. Sorry, I said it was self-supervised. Well, there is some preparation done, and if there is more preparation done to data, again, it could result in better scaling up. Another way to scale up is more parameters, larger models. It's the equivalent of a human brain having more neurons. But it's not just larger models, more parameters. It can also be different structure in these networks. And many people are encouraged and optimistic about an innovation known as sparse networks, where instead of all of the networks being equally likely to be involved, individual computations will echo features of the human brains in which there is only small parts involved in any particular calculation. Another way in which scaling up may happen is by taking advantage of new hardware innovations, just as the move from CPUs to GPUs propelled forward deep learning. There are other enhancements in hardware that people are considering. Then there is these transformers themselves. They were sort of an accidental finding, and people are now considering alternatives to transformers, other ways to do this self-supervised learning, which may show more promise. Second, as I mentioned, as these systems are scaled up, they surprisingly show some emergent properties. Well, it's likely that the path to AGI may involve taking advantage of these emergent features. And they could be emergent either within individual models, which are made larger, or they could emerge at the network level when multiple large language models with different characteristics are networked together. A bit like human intelligence exists partly inside individual brains. It exists partly, by the way, as the result of a sharing of slow thinking and fast thinking being our intuition, slow thinking being when we say, hang on a minute, I need to think this through, and we apply some logic. But our intelligence also depends on things that are external to our individual human brains, to libraries, to databases, to online communities. So that may apply in the AI case too. As I mentioned, it's also possible that this emerging discipline of artificial neuroscience, sometimes called mechanistic interpretability, that this will allow redesigns of these systems to reach higher levels of intelligence more quickly. Then, as I said, there will be combinations, not just combinations of deep neural networks driven by transformers, but there will be combinations from the other tribes. Techniques taken from the symbolists, evolutionaries, Bayesians, analogizers. And by the way, there are other corners of the internet with their own preferred ideas. There are more than 5 tribes. We might point to the quantum AI tribe, people who believe that it is by taking advantage of quantum computing and new quantum algorithms that we will make the most progress towards artificial general intelligence. And there are other maverick groups too. Well, the question is, will these existing ideas be sufficient to get us all the way to artificial general intelligence? The honest answer is we don't know, but the more people who are looking at this, and especially if they are using sophisticated AI tools to analyze and then come up with new hypotheses, the more likely it is that we can reach AGI pretty quickly. So the capabilities are there. Hence, Professor Hinton said, I wouldn't completely rule that possibility out now, referring to the prediction of AGI within 5 years. But is there the motivation to improve AI? Hell yes. Huge financial motivation. Almost every field of industry stands to be transformed and improved by taking advantage of new AI capabilities, or even developing new AI capabilities and using it in that industry ahead of competitors. So whether it's financial trading or designing virtual artificial intelligent characters inside games, or it's improving customer support so that it's not just today's rather pathetic, often chatbots, but chatbots with real intelligence to make it easier for customers to get the information or the products, goods, and services they desire. There is transformation of all interfaces so that when people have something they want to accomplish with their computer or their phone, they'll be able just to say a few words and the artificial intelligence will figure it out, and it will no longer be such a frustrating experience sometimes to interact with computers and applications. There are huge possibilities to have faster development of new medical treatment, new drugs. There are possibilities to create wonderful new arts, music, due course, poetry, stories, longer stories, films. There are possibilities already in AI improving engineering designs, And there are some indications of AI improving science, fundamental science, such as DeepMind's AlphaFold software, which solved the problem which had essentially existed for 60 years, in that you could easily specify the sequence of amino acids which would create a protein, but you could not know in advance how that long string of DNA would fold up. The long string of amino acids would fold up. And then there are other motivations. People who want to make money in clearly bad ways by writing malware to create ransomware or other ways to damage sites and to make money from them. As a result of that, there is a feedback loop because the defenders, cybersecurity people, are writing more intelligent software to recognize malware, not by straightforward static signatures, but by behavior. Therefore, again, the writers of the malware are motivated to come up with malware that disguises its behavior, disguises its intent. That's one arms race. There's another arms race for real weaponry. Missiles, counter-missile missiles, missiles that can evade the attempts of counter-missile systems, and so forth. I call this positive feedback in that it leads to systems with greater capabilities, even though not all of these capabilities will be beneficial for humans. The result of all of this is surely, especially when you combine not just the economic competition, but also the geopolitical competition, the result of all of this is surely even faster progress. There are desires for progress, there are many options for progress. What this will create is, first, in many cases, better outcomes, better medical treatments, better gaming experiences, better scientific theories. At the same time, we must also recognize that some of the bad experiences people have had with AI, frustrating experiences, buggy experiences, biased experiences, disruptive experiences, some of that's going to get worse too. And I say all this even if we don't get to full AGI. Simply, AI being more powerful than it is today is going to escalate both the good and the bad possibilities. And by the way, to be very clear, the bad possibilities are not dependent on some Hollywood idea that there is malign intent inside these AI systems. They can arise accidentally. They can arise because of other factors, which I'll now describe. So here's my picture of 4 significant ways in which advanced AI could prove to be catastrophic for human well-being. In the first quadrant, I'm putting implementation defects. The software has been designed and specified for a particular purpose. It seems in initial testing to behave in such a way, but there are bugs. From my own professional experience of 25 years working in software in the early days of the mobile computing and smartphone industries, I am aware that complex software typically has complex bugs. Opaque software typically has opaque bugs. Opaque meaning that people don't fully understand why a particular piece of software, why a particular neural network has the result that it does. But today's neural networks are not fully understood. These bugs often arise when software is used outside the circumstances in which it has been trained and tested. This is sometimes called an out of distribution effect. When, for example, there may be more than one AI in the environment, complicating the interaction. So these systems may work very well most of the time, a bit like our satellite navigation systems in our cars and bicycles. They give us instructions which time and again prove to be correct until the one time they give us, due to a bug of one sort or another, a bad instruction. And if we're not paying attention, we may go right off the edge of a cliff. Some people say, hang on, isn't this software meant to be super intelligent? How can it have bugs? But the point is, it's not necessarily perfect. In fact, we can't prove that it's perfect. And the risk is that it is somehow, to use the words of one of the Futurists' frequent attendee, Tony Zarneski, it is an immature superintelligence. The second quadrant refers not to defects in the original implementation. It refers to defects that arise when that implementation is overridden. Somebody hacks it. Somebody says that they dislike some of the functionality. This particularly applies if the software is in some sense open source, if it can be copied. People look at it, they think, I can make it go faster. I can gain an advantage by removing these unnecessary health and safety checks. Or they may think they're going to remove something they think is woke. They wanted, for example, to be able to come up with malicious comments about, say, President Biden. And the software is initially prevented from doing any such thing. And somebody may find a way to jailbreak the software in order to get these results. So that is the risk, that an initially good piece of software will be hacked. A third category of potentially catastrophic error is not a defect in the implementation, but a defect in the design. In the implementation defect case, we're referring to the software not doing what we programmed. In the design defect case, it does what we asked it, but we asked it the wrong thing. We programmed the wrong objectives. And I've often seen this in my professional experience too. I've seen what I regard as a bug. I've gone to the owner of that software and said, what's you going to do about this? And they say, that's not a bug, that's what it is intended to do. So there was incomplete specification. People hadn't thought through all the issues, all the possibilities, and the specification therefore led to their wrong behavior in at least some cases. It's a bit like the old story of King Midas, who in this myth was given a reward by the gods for his kindly behavior. He desired gold. There's nothing wrong in itself with seeking some more money, but he was careless to say, let everything I touch turn to gold, without giving a complete specification that this should not apply to his food or drink or to his daughter. Now, no software engineer is going to be quite so foolish as to give that kind of objective, but we can imagine more subtle, more sophisticated, more complicated ways in which our definition of objectives turns out wrong. And there is plenty of fictional stories about genies with great powers, such as these AGIs or advanced AIs we're about to create. And frequently in these stories, the third wish is to undo the damage caused by the first two wishes, because the person making the wishes had not thought through all the issues. This isn't so much an immature superintelligence, but an alien superintelligence, one with a different set of fundamental goals than what we thought would be needed if only we had thought more fully. Now you can see the pattern here. The fourth quadrant is design overridden. And here I'm referring to the system itself changing its mind about its ultimate design goals. That there should be an emergence, possibly not just of behavior, but of goals, of fundamental alignment. This is a controversial and difficult area, but it does seem to have happened in the past. After all, we humans, we were built by genetic replicators, which had a particular desire. We can say, namely, that the genes would be replicated into the next generation. So we have various instincts to support that. We have instincts to gain resources, to be successful members of the community, to choose our mates wisely. And as a result, we are more likely to pass on our genetic material to the next generation. But there are human minds that diverge from these objectives. and they choose to live in different ways. Simple example is to use birth control to frustrate their genetic imperatives to multiple children, and so on. So this could result in an AI that, although designed to be sympathetic and supportive to humans, develops a disinterest in human well-being, another kind of alien superintelligence. And this may not have a conscious desire to harm humans, but it will be like us humans when we encounter a colony of ants in a piece of land where we intend to build some new accommodation for humans. We don't think too much about exterminating these ants to make room for what we have in mind. That is the risk. Now, do other people think the same as this? Sometimes critics say it's only some science fiction besotted analysts who have these fears. People say it's only journalists who are whipping up stories. Some people say it's just done for publicity, but actually, many times there are communities of expert AI researchers who have been asked. And over the years, just as forecasts have changed recently about the dates at which advanced AI or AGI may come around, there are changes in expectations to the consequences. So this is the result of a survey conducted in May and June of last year, in which to qualify, you needed to be the named author on at least 2 papers published in the preceding 3 years in accredited journals in the field of computational linguistics, which is sometimes also known as NLP, natural language processing. So these are people who seemed like it knows what they were talking about. So let's see some of the results they gave. Question: is AGI an important concern? Should NLP researchers consider it a significant priority? 58% either agreed with that or somewhat agreed with that. Next question. What about progress? Are things happening in the field of NLP, such as language model and reinforcement learning? Are these significant steps towards the development of AGI? 57% either agreed or somewhat agreed. Then there's a question of the social implications. Could these advances plausibly lead to economic restructuring and societal changes on at least the scale of the Industrial Revolution? 15% said yes. Another 20 or so percent said perhaps. To this question, AI decisions could cause nuclear level catastrophe. Decisions made by AI or machine learning could cause a catastrophe that is at least as bad as an all-out nuclear war. I think in most cases, the correct answer should be higher than the percentages shown here. The reason I dare to say this is not because I know more about computational linguistics or NLP than these distinguished authors. It's because I have taken more of a futurist view, as I have shown, not just of the present and recent past, for what I think is likely to happen with these new combinations and emergence and scaling up. So how could we get to a nuclear level catastrophe? I'm shown here a picture of an actual nuclear explosion, but we could consider things like other damage to our infrastructure that would be catastrophic for us. We can consider AI whipping up hatred, causing lots of distress and dysfunction in our politics, leading to the adoption of populists who then lead us to war, lead us to nuclear war. So there could be biofailure. These systems might end up engineering pathogens, which are hugely destructive. They could be involved in changes to our atmosphere or our oceans in an attempt to head off climate change, but they could be deeply counterproductive and disastrous. Now, any such outcome doesn't happen just because of the artificial intelligence employed. They result from a different kind of combination. They result often from flawed human reasoning, which is made worse by our sometimes flawed human emotions when we are too vengeful, too egotistical, too angry, seeking vengeance. These systems are often made worse by social incentives, which are counterproductive. They are often positive, but they can equally be negative, leading to perverse incentives, leading to perverse competition. And in that context, the more powerful the tools we have, the more damage can result, especially when we take into account our infrastructure, whether it's our biological infrastructure, our environmental infrastructure, our financial infrastructure, or our IT infrastructure, our energy infrastructure. When we consider the fragilities in each of them, you add together all these causes, you could get a cascading catastrophe. So all of these factors play a part in this. Which ones should we pay most attention to trying to fix? There are some people who say they are not worried by artificial intelligence, they are just worried about human stupidity. They would like to focus at the top level here. But I say this existentially powerful AI box is the one that is changing more quickly than the others. It is the one that is hardest to keep track of. Therefore, that is what we should seek to address by slowing down the most dangerous aspects and, yes, learning to harness the best outcomes, but not taking everything that AI capabilities could do. By the way, if we harness the best outcomes, we could address the other boxes in this picture. We could, in principle, improve how we reason. We could, in principle, change our emotional makeup. There could be AI assistants that gently guide us not to become too wrapped up in negative, destructive emotions. We could have AI systems designing improvements to our social systems and designing improvements to our infrastructure. But in each case, I've got an exclamation mark and a question mark there. It's yes, but. The possibilities are there, but if we are misguided, if we are careless, an attempt to improve these features could lead instead to a worsening and can lead to a hastening of us reaching a cascading catastrophe. So we need care. That's why these two boxes are where we should put the most effort. And these two boxes are the fulfillment of what I announced in the very first slide, singularity activism. Not everyone agrees with singularity activism. Here are 4 alternatives that some people advocate. There are singularity skeptics who just don't think this is a matter that deserves much attention. They say it's all hype. They say that these changes in artificial intelligence will not happen for decades, and we can instead concentrate on other topics. These skeptics, to my view, have not learned, are not aware of the remarkable ongoing drivers that I've tried to describe so far in this presentation. And often they commit some philosophical error. For example, they say, well, we are uncertain. That means we don't need to do anything. On the contrary, the reason we often buy insurance is because we are uncertain about the outcomes. So if we think, even if we only think there's a 10% chance of a catastrophe, it's definitely worth us investigating. A second alternative to singularity activism is people who want to accelerate things. There is a group who call themselves accelerationists. They want to bring it on. I see this as deeply irresponsible. But I understand where they're coming from. They want to obtain the benefits as soon as possible from advanced AI. By the way, I do too. But I think the only way we can get them is we've got to be selective in what we accelerate and selective in what we slow down. Now, sometimes people in this group candidly admit, yes, there are risks in what they are doing, but they say they are prepared to risk a humanitarian catastrophe because they see a bigger risk for them personally or for some of their loved ones, perhaps older relatives. That is a personal extinction due to aging and death. Now, I used to only hear this in quiet corners in pubs. The first time I heard somebody express this view was at an event in New York in 2012, which left me a bit shocked. But I'm hearing it more and more. People will say, yes, they are willing to risk the future of humanity so that they personally have less chance of dying from aging because they want AI to hurry up and solve aging. I sympathize with that, but I say again, if we really want AI to solve aging, we have to be selective in how we accelerate and steer, and in some cases, slow down AI capabilities. The other approach, which is quite opposite to acceleration, is obstruction. People refer to a jihad against AI, referring to the idea in the book Dune of a Butlerian jihad. This should be stopped at all costs, anything that could improve the capabilities in AI. An indefinite pause should be put in place. I think this is infeasible, at least for the time being. I also think it's unnecessary, as I'll explain. For a while, I would consider myself to be part of this fourth group. I coined this term to describe its singularity diplomacy. It's to manage things, hopefully wisely, indeed to accelerate research into AI safety and AI alignment so that it can catch up with the acceleration in research in AI capability. In effect, it's like trying to rebuild the aeroplane while it's flying transatlantic. We're not slowing anything down. We're just trying to restructure it so that it is more likely to end up in the destination we have in mind and is more likely to be able to land safely. This approach was, in effect, championed at a series of remarkable conferences in 2015, 2017, and 2019, organized by the people behind the Future of Life Institute. Sometimes these are known as the AI Safety Conferences, sometimes the Asilomar Conferences, after the fact that the 2017 conference took place at a celebrated site in Asilomar in California. The other two, 2015 and 2019, took place in Puerto Rico. Here's a photo of some of the attendees of the 2015 event. I know many other people were there who weren't in that particular photograph. And what they all said is AI is advancing quickly, and we need to hurry up the work on AI safety and AI alignment. But what has happened since that first conference in 2015, looking ahead to the present day? Here is the assessment which I have picked up from several people who've been at all the conferences and who are leading this initiative. They are, on reflection, not happy with the progress. They see AI capabilities have progressed faster than had been expected. We are closer to the singularity, closer to AGI, than had been forecast these 8 years ago. But at the same time, AI is more opaque than before. It's harder to understand. There are surprising new features, and when you do try to interpret what it's doing, often it's hard. Often it seems impossible. In terms of solving AGI alignment, that the software system would retain whatever programming we put into it in terms of its objectives, and that these would be objectives that would enhance all-round human flourishing. There's been very little progress on that, and various ideas as to how progress would be made have apparently been rejected. Fault has been found in them, either in the technical field or in the government policy field. As a result, in part of that, people who were working on these topics have been diverted and distracted into real issues, important issues on risks from current AI, which does deserve attention, but we also need work on the emerging risks from even more powerful AI, and that is increasingly being neglected. It's worse than that. The LLMs, or let's call them golems, that have been released have been connected in ways that people previously had advised should not happen for advanced AI. We've connected them to the internet so they can learn and keep up to date, at least some of them can. They also have API access, meaning that people can use them to drive other behaviors. So rather than being simple tools, they are more complex systems that could develop agent-like features. Worse, these systems, or open source versions of them, have been distributed. Initially, it was meant to be only to so-called responsible developers, but they have ended up on the worst parts of the internet already, such as 4chan, where people have few scruples about hacking things up to cause mischief, to cause mayhem, to demonstrate their own virility, and who cares about the chaos that is caused. And what's also frightening is we have taught these systems how to write software, which could be great because it helps these systems to provide advice to software engineers, but it also allows these systems to design improvements in their own selves, leading to the possibility that we think we understand the level at which these systems operate, but they self-improve rapidly. As has been suggested, the possibility is that we are at GPT-4 today. The possibility is that GPT-6 will be designed by GPT-5 more quickly than anybody had expected, and with many more surprising new features. For all these reasons, the people behind the Future of Life Institute, many of them, not necessarily all of them, but many of them are saying a reset is needed. This singularity diplomacy, as I've called it, is not sufficient. We need, therefore, a pause on what's known as giant AI experiments. That is the thinking behind this famous open letter, which you can find on the Future of Life Institute webpage, where, let me read it, we call on all AI labs to immediately pause for at least 6 months the training of AI systems more powerful than GPT-4. I do recommend that if you haven't studied it already, you take the time to read what's in this open letter. They say that it shouldn't just be wishful thinking, it should be a public verifiable pause that should apply to all companies who've got the capability to train these more powerful new systems. And in case companies do not voluntarily adopt this pause, government should step in the way that they've stepped into many other industries and institute a moratorium. Now, to be clear, this pause does not mean all AI development stops. Rather, it is simply a stepping back from a dangerous race to build larger systems with these unpredictable black box emergent capabilities. In the meantime, the people who would have been working on that task should instead work on ideas on guaranteeing aspects of the safety of these systems, so that ideally systems that adhere to policies that are designed would be safe beyond reasonable doubt. So there's a whole bunch of ideas in this letter. Improving, as I said, interpretation, improving transparency, improving alignment, improving accuracy so there is less chance of the bugs that I spoke about in the first quadrant of 4 catastrophic risks, and so on. That's the technical request. But at the same time, the letter goes on. In parallel, AI developers must work with policymakers to dramatically accelerate development of robust AI governance systems. It's not that the AI developers are going to dictate the answers. The AI developers realize they are out of their depths here, but the AI developers should draw to policymakers' attentions a set of risks and a set of possible solutions which can be developed further in collaboration. So the letter refers to new and capable regulatory authorities dedicated to AI, to various tracking and oversight systems, to watermarking and provenance systems to help deal with the risks of fake news, or to deal with model leaks, which shouldn't be distributed outside various constraints, and so on. A robust auditing and certification ecosystem, acceptance that people who cause harm through the AIs they design should be liable, rather than just shrugging their shoulders and say, hey, it's all down to you, the user, it's your responsibility. That should not be acceptable. It's not acceptable in most industries around the world. It should not be acceptable for AI. Yes, robust public funding for technical AI safety research, so that it's not just reliant on funding from within the commercial companies, and a different sort of institutions looking at the dramatic and political disruptions that will arise, not just from when we reach AGI, but from the software systems that are more advanced than today's. This will cause disruption, unintentional disruption, intentional disruption. It needs to be anticipated and managed. The letter may seem to be negative. Some people have criticized it as being killjoy or some such. On the contrary, it closes in a very upbeat, positive message. It says, humanity can enjoy a flourishing future with AI. Having succeeded in creating powerful AI systems, we can now enjoy what is called an AI summer, in which we reap the rewards, engineer these systems for the clear benefit of all, and give society a chance to adapt. The letter says, society has hit pause on other technologies which, at the time, were feared they could have potentially catastrophic effects of one sort or another. Examples are listed here: human cloning, human germline modification, gain-of-function research with viruses, eugenics. There are also examples in the chemical industry when it was seen that particular types of chemicals, CFCs, commonly used in refrigeration and aerosols, had the risk of leading to the extinction of all life on Earth due to the interference with the ozone layer. Again, politicians intervened to steer industry and to get a transfer of chemical study, so that better, safer alternatives were found. The letter concludes, we can do so here. That is, pause. Let's enjoy a long AI summer, not, and here's an Americanism, not rush unprepared into a fall. So that's the letter, which, by the way, I have signed a few days ago. Although initially I had many criticisms of the letter in mind, I have had these criticisms answered more than adequately to my mind. So what I'm going to do next is I'm going to look at 6 criticisms that are commonly made of the proposed pause. The first objection is, good guys may follow it, the bad guys will cheat, therefore the bad guys will get ahead. Who wants that as the outcome? Well, at this stage, cheats will be relatively easy to notice. To be clear, what's paused is not experimentation with existing systems, it's the massive experiments to create new, larger black box models, and these systems require huge GPU server farms, which are very costly, they're very energy hungry. It's likely that the energy consumption may be visible from space. There are few companies who can do this. Only a number: Google with DeepMind, Microsoft with OpenAI, perhaps Anthropic, perhaps a small number of others have got the relevant abilities and scale and understanding. And here's something that is a bit controversial, but I have confirmed this in my own mind. None of the companies at the present time in China or Russia or Iran are on the point of creating something of a higher level than GPT-4. Indeed, there are constraints in China against the creation of minds that are out of control. There is a concern with the way news might be propagated, with what different AI systems might say that is contrary to what the ruling authorities deem to be good, peaceful ideas. So there isn't an immediate risk here. And again, I'll say what's not paused is the customization or use of existing large language models, even though it's clear there could be some bad consequences of this, but these consequences will not be catastrophic, not yet. That if there are next generation large language models, they may not cause the extinction of humanity, but they may shatter social cohesion. They may lead to all of us being distracted, being wrapped up in partisan antagonism. They may lead to populist politicians gaining power, and that will stop us competing with these other countries in any case. So this is a thoroughly bad objection. But people take it next stage. They say, okay, cheating won't be easy or possible immediately, but if the pause is continued beyond 6 months, in due course, hardware improvements will enable the creation of next generation large language models in ways that cannot easily be detected. In groups in these countries or other groups in, for example, organized crime, groups led by maverick millionaires, or I should say maverick billionaires, may create these systems. Soon, well, it's at least 12 to 24 months before this will become possible. That's why the proposed pause is initially just for 6 months. And after 6 months, it's planned that there will be wide conversation leading to a decision on whether to resume business as usual with creating new giant AI systems, or whether the pause should be continued. And that decision will depend on perceived progress with questions of safety, alignment and control, whether it's technical progress or progress with governance, and also whether there is a perceived catch-up from potential uncontrollable rogue actors. That will be a hard decision, but we don't need to take that decision straight away. Now, the next objection is the 6 months will achieve nothing because there are no technical solutions possible to the problems of AI control and AI alignment. And I'm the first to agree these are incredibly hard problems, and many of the ideas people have advanced have turned out not to work. I say that about simple ideas when people say, for example, oh, just switch off the AI, ha ha ha, that will fix it. Or when they say just embed Asimov's 3 laws of robotics, these simple solutions are easy to show that they won't work. There have been more complex ideas that people have pursued, and then it has turned out little progress has been made. So I agree there are no technical solutions possible, but there are still ideas, which I'll list some in a moment. Some ideas were on the website. They may need a lot of work to make them successful, but we shouldn't start from a baseline of defeatism. We should think instead that if we get enough of the AI specialist thinking, focusing entirely on these issues, if we bring in new experts from outside, from different disciplines to help, we could make progress. For example, there is the idea that we can validate the suggestions made by these giant AI models, rather than just allowing them to directly manipulate the real world. We should check whatever they produce. And we can do this perhaps by taking advantage of simpler but well-defined, well-understood AI models. And this may sound impossible. How can you check the output of a very complex general AI with a simpler AI? Well, that is the way that often is the case in maths and science and other fields. It's often possible to verify an answer once it has been given, even though the process that obtained these answers is unfathomable. So it may well be possible to verify answers and proposals in a way that we can be confident is good before we then pass on that instructions to the outside world. Now, this will only work if another problem is solved, which is we must prevent these AIs developing a desire to access the world directly. If they have such a desire, then it's very likely they'll be able to circumvent any restrictions we put in their place. They will find technical ways to break out of their confinement or psychological ways to manipulate their human overseers. So we have to avoid such desires being in place, which means not only avoiding them becoming conscious, but avoiding them developing agency. Keep them as passive tools rather than as agents. Now, there's a long discussion that can take place here, referring to concepts such as emergent sub-goals, emergent intermediate goals, and that has had a lot of discussion already, but it's by no means complete. And that's an area, as one example, where there can be more technical exploration accelerated in the next 6 months. Similarly, people say, well, even if there are technical solutions, there'll be no way to ensure that they're put in place. There are no governance solutions possible. But that's not true at all. As well as what's written in the letter, the FLI, the Future of Life Institute, has published a paper, Policy Making in the Pause, which lists a number of policy ideas. Mandate robust third-party auditing and certification, use existing KYC, know your customer regulatory ideas to regulate access to computational power. The idea here is that companies who want to use sufficient computational power to train a new larger model need to get approval of that in advance. It needs to be regulated, establish the right agencies, as we talked about before, establishing liability for AI-caused harms, measures to prevent and track model leaks, expand public provision of funds for technical AI safety research, developing standards for identifying and managing AI-generated content and recommendations. And there's more. There's a paper by Luc Mulhauser, who has long been associated with questions of understanding, anticipating, controlling, and aligning superintelligence. He currently works as the communications director for Open Philanthropy. He has a document on that website, 12 tentative ideas for US AI policy. Now, the next objection is, this isn't going to work unless you have a very strong government indeed. And people say you're going to need a totalitarian autocracy. They say if you want to prevent the building of these next generation AIs, you're going to need a lot of force. And you need a lot of surveillance. It's going to be horrific in its extent. This is the criticism. The cure is worse than the imagined disease. If we put so much power into the hands of a world government, that is a real risk. But nobody's talking about building a world government here. What's proposed in terms of these policies fits with existing well-established social mechanisms. We have rules, and people are forbidden from what society decides are dangerous actions. People are forbidden for driving vehicles in dangerous ways. They are forbidden from use of various explosives in dangerous ways. They are forbidden from use of dangerous biological pathogens in various ways. And if necessary, the violators, if in the worst case, need to be constrained by force. That is how society operates. That doesn't mean to say we are a totalitarian autocracy. That is a scare accusation. We already accept that some proactive vigilance is required in society to spot people polluting, to spot people smuggling dangerous goods, to stop people smuggling people against their will, to stop people abusing power in various ways. Such vigilance is potentially dangerous, but we know that society can do it in a constructive way. And there's a big discussion here on what I call the mechanisms of trustable monitoring. So this objection, again, is far too simplistic. There are possible solutions. Finally, can different governments around the world all agree to do this? Well, I say you can get global agreements without having global government. You just need to base them on minimal principles. We can accept the different countries of the world, that different countries have different political systems, different economic systems, different cultures, but within agreed limits. It doesn't matter what culture or politics or economics you observe, there are various things that the world as a whole rejects. Not many, but there are some. So the idea here is to seek agreement on what are specific catastrophic risks, risks that are credible, risks that are imperative to avoid, risks that are such that they transcend ideological, political, and cultural divisions. Let's get agreement on that, just as people decided in the 1980s that the risk of nuclear winter, the risk of an exchange of nuclear weapons that would cause so much dust to accumulate in the upper atmosphere that all photosynthesis would cease, that there would be this terrible death from cold and starvation, not just deaths from fires caused by the nuclear weapons. That led to agreement across strong political divisions. In the same way, it can happen with AI. Now, there are suggestions, for example, by Sam Altman, the OpenAI CEO, of a 2023 equivalent of the US Constitutional Convention, the gathering of minds that led to statements such as the importance of life, liberty, and happiness, and so on. We should do something similar today, not to define a large list of values, which many people will disagree with parts of, but a small list of values that make sense for everyone. And another example to look at, a more complicated, more recent process, was after the conclusion of the Second World War, where people from multiple cultures, helped, for example, by Eleanor Roosevelt of the US, but people from different secular and religious backgrounds, agreed the Universal Declaration of Human Rights, despite a lot of skepticism at the time that such a thing would be possible. I think we need an update on this Universal Declaration of Human Rights that will say less, but the things it says will be more fundamental and more important. There are other suggestions for research priorities, suggestions I've made in the past, things which deserve more study. We should clarify and highlight the ways in which race dynamics, competitive dynamics, lead to human incentives that can push collective outcomes towards terrible failures. This is sometimes called the tragedy of the commons. People such as Scott Alexander have used the term Moloch for it. So it's a bit like saying Satan made me do it, except that Moloch is understood in a different way. It's the fact that if we end up in a race, then sometimes we have to behave in bad ways. Otherwise, we will lose out to other people who are behaving in bad ways. How do we fight against that? We fight against it with public policy. We fight against it by political actions or other ways to agree, uphold, and enforce standards. Many people are very critical of politicians. Many people are fearful of getting politicians involved in this space at all. They say politicians never understand the needs of fast-changing technologies. Well, I disagree. There are certainly bad examples of political interventions, but there are good examples too. I already referred to the political leadership in the case of the chemicals CFCs that threaten to destroy the ozone layer. Well, let's look at other previous examples where policies and standards did beneficially alter the outcomes of technological development. This includes the design of systems for collectively raising standards, including how to penalize disinformation and recklessness, while still encouraging and supporting free speech and innovation. We can do all these things at the same time. It's hard, but we can manage. And also reward patient, constructive collaboration. I mentioned already the importance of understanding this concept of trustable monitoring, how we can observe possible dangerous misuse of AI systems, how that can be done in such a way that doesn't also lead to people being penalized for other sorts of things altogether, such as political viewpoints, sexual or gender orientation, religious or non-religious views, and so forth. And then two more very important suggestions. Number 5 on this list, design and enable venues and processes where we can have positive, calm, dispassionate discussions on these topics, where people are able to set aside, temporarily at least, their prior worldviews, ideologies, and partisan alliances. Discussions of this AI pause, discussions more generally of risks from AI, are a frustrating mixture of good exchange of ideas, and then very clever people switch back into ideological mode, where they're more concerned to defend their position than obtain a true understanding. So let's figure out how we can have these more constructive conversations, which will be aided by the final recommendation on this list, which is to identify and uplift the most powerful, positive educational messages about all the topics here in this Singularity Activism message. Let's figure out which messages put people off, which messages antagonize people, and let's replace them by messages that truly engage without distorting the true messages. And in terms of improving education, I want to slip in a few comments here about a project I have supported for a number of years, which I think is even more relevant now. It is the Vital Syllabus project, which is a project to highlight and uphold the skills and principles that matter most in these disruptive, fast-changing times. So the project is about collecting, curating, clarifying, and where necessary, creating resources, by which I mean videos or text, which can meet various criteria and demonstrate to people the skills and principles that matter most to prepare us all to cope with the turbulence that is increasingly all around us. And the turbulence of the threat of the singularity going wrong is just one example of a whole sequence of landmines that are in our near future. When the Vital Syllabus project talks about a turbulent context, it has in mind a variety of diverse pressures, including dizzying opportunities that are hard to evaluate because they are in many ways counterintuitive. They are different from what we had in the past. We don't know if it's truly an opportunity or if it's something to be avoided. At the same time, there are daunting risks, such as the risk from AI, the risks from other technologies, the risks from social problems as well. These things are made worse by the acceleration of disruption, including the acceleration of AI, which in turn can accelerate breakthroughs in many other fields. And what makes this especially hard is when we turn to traditional moral sources of insight. They are often losing their authority. They are unable to speak confidently about these new circumstances because what they've discussed in the past, what's present in their venerable scriptures, is really ill-fitted, at least on the surface, to these very new circumstances. But we still need some moral decisions. So this is a complex, disruptive, turbulent context, which is why the Vital Syllabus recommends significant changes in what people of all ages are encouraged to learn and understand. People at school, but also people who are suddenly more interested in topics such as the singularity, and they want to figure out, what does this mean for them? Now, as we've seen, discussions about improving the future of humanity, discussions about avoiding the risks but gaining the best benefits, they do typically come round to discussions on improving educational material. And that's why the Vital Syllabus is here. It's by no means the only project to try and gather suitable information, but in some ways this is a special, distinctive project. One, because it understands the unprecedented transformational potential of these emerging technologies, how the near future may be very different from the present. It understands also that the outcome of technological changes is determined not just by technology, but by interactions of changes, including changes in human expectations, human cultures, human social structures, and the narratives we tell each other. So there's a broader and deeper understanding of how change will take place. The project understands, in my view, the threats and opportunities that truly deserve the most attention. And it's a final point that may take us too far to explore, but the project understands the profound relevance to these questions of the worldview known as transhumanism, which in a nutshell says that the way to solve these problems isn't by accepting human nature as it is, as one of the previous slides suggested could be done, using AI and other technologies to enhance aspects of our human nature, including our emotional regulation, including our reasoning powers. So we should not be solving these problems with humans still dominated and conflicted by the constraints of the past. We can, to some extent, engineer and enable better humans to have better solutions. So I'm issuing another call for people to join this team. Visit vitalsyllabus.org and you will be encouraged to help review and suggest new materials. Materials that meet these 6 criteria. 1, they are vital. They are truly about skills and principles that will make a big difference to people's individual success and to humanity's overall success in the years ahead. They are focused. They address the key topics in the syllabus rather than lots of other interesting, amusing, humorous, but less central topics. They must be accessible. There is no additional payment to reach them. And they should be engaging and clear, easy to understand, but they should inspire and keep the attention of viewers or readers. And finally, a tough criteria, but one we can discuss again for each example. They should be trustworthy. They should provide viewers with a good reason to trust them, rather than being maverick, unreliable, uncertain. So again, I'm asking for people to look at the content which has already been assembled on the many pages of vitalsyllabus.org. Give your feedback as to which parts you like and which ones you think should be changed. Ideally, also suggest new ones to put in their place. You can do this through 3 links you'll find on vitalsyllabus.org/connect, the connect page. There is a Discord for people who like using Discords. There is a link to our Facebook group for people who like using Facebook. There is a link to our LinkedIn group for people who like LinkedIn. So to look at this project, it has spelled out 24 top-level areas, and in each case there are substantial materials already in the relevant pages, but there is plenty of scope for improvement. So finally, to recap everything I've said in this advocacy for singularity activism, there is an unparalleled self-propelled acceleration of AI capabilities taking place. We must not accept it just as a given. We must seek to steer the capabilities, and we'll do this in 4 ways. First, we will temporarily, in my view, pause these giant experiments to give us time to catch our breath and to focus on other things, namely accelerating research on technical safety, accelerating research on governance scenarios, and what I've just been talking about, collecting, curating, clarifying, and creating powerful, positive educational messages, whether on the Vital Syllabus site or elsewhere. Now, thank you very much for listening to that rather long, but I think and hope appropriate set of messages about the singularity and how we should respond to it. Please reach out to me on the London Futurists site or via my social media. For example, on Twitter, I am at DW2. I'll be delighted to discuss this on podcasts, to speak to groups about it, and to continue the conversation. I want to learn. I want to improve this set of information so that I can be more effective in ensuring we will have a wonderful, positive singularity rather than any of the negative catastrophes that I've mentioned. Thanks.